Okay, today we'll take a look at conditionals and recursion. This is chapter 5 from the Think Python textbook, and I'm also going to talk about lists, and well, we'll see how far we get along. Okay. So I also have the notebook that has all of this stuff running as well, but basically you can do why are the results not showing? This is no good. What? I'm sorry. Something has happened. Okay. When I execute this, it's supposed to, let me try this one more time. Okay, so if you pulled the changes I pushed, the results aren't showing. Okay, what I wanted was the results to show, but none of the results are showing. This is worthless. Okay, that is highly disappointing. Okay, well, I guess I will just have to go off of the notebook and hope you guys can see and read this. So weird. Okay. Okay, well, anyway, regular old division, 105 divided by 60 tells us it's 1.75. We looked at kind of floor division, where it just gives you the integer portion of that response, okay? And the modulus will give you the remainder, right? So after you divide 105 by 60, it goes in there once, and then you'll have 45 remainder, and that's going to be the mod operator, okay? And so you can use mod 2 to kind of see if a number is even or odd. You can just check to see if a number is divisible by another number. So here, I've got 5 divisible by 2. Is that equal to 0? And it returns false because 5 mod 2 is 1 and it's not 0. Whereas 6 mod 2 is 0, okay? There's no remainder left over after dividing 6 by 2, so we get 0. Okay, simple enough. We also have these Boolean expressions. The Boolean expressions just evaluate something and return either true or false. It doesn't actually do any kind of operation in terms of assigning a value or anything like that. Just returns true or false. So 5 equal to 5 is true, 5 equal to 6 is false, 5 not equal to 6 is true, 5 greater than 6 is false, 5 less than 6 is true, 5 greater than or equal to 6 is false, and 5 less than or equal to 6 is true. So there's no surprise here. I think we're totally accustomed to seeing values like this. The logical operators, okay? So this takes a tiny bit of getting used to if you're coming from another language like R, is you type out the words and, or not, okay? So if you're coming from R, you might be used to using something like the ampersand sign or the vertical bar or an exclamation point for not and things like that. In Python, we just use words, okay? So true and true make true. True and false is false. True or false is true, okay? And then not true, false, not false is true. False or not false will be what? True. And then true and not false is also true, okay? So these are all logical operators. The important thing to note is that we write these words as or not in lowercase letters. They are reserved keywords. You cannot use them in, you can't assign values or use them as variable names or something like that. So they are reserved, and reserved words generally, as you are typing them in Python or in the Jupyter Notebook, will show up as in this bold green text to kind of let you know that what you just typed is a reserved word. So don't try to do anything with it, okay? All right, so can you guys see the cell? What will this return? N equals 6, N mod 2 equals 0, and N mod 3 equals 0. What's that going to give us? Should be an easy one, right? So n mod 2, 6 divisible by 2 is true. And n mod 3 is also going to be 0. 6 is divisible by 3. So we got true and true. So as far as 6 goes, we get true, okay? If we do n equals 8, yeah, thank you, Tyler, for participating here. N equals 8, we do n mod 2, that's going to be 0, and so the first statement is true. The second statement is false because 8 is not divisible by 3, so true and false make false. 8 does this, but then if I switch it out with an or, this part's true, this part is false, but the or statement will return true. Okay, easy. All right, and so now we just move right on in to conditionals, okay? And conditional statements or if statements, they start with an if. You put in a logical expression. That logical expression is either evaluated to be true or false, and then there's a colon, and then and after the colon, there's indentation. And indentation is how we know that a statement, how we know if the statements are associated with the if statement, okay? So, a second. So what we're gonna do is we've got x equal to 5, all right? Then I write the if statement, right? If x is greater than 0, colon, indent, print x is positive. Okay, so when I run this, it's gonna say, well, let's evaluate x greater than 0, that's true. So if true, then it runs the statements associated with the colon, which are all the indented lines. In this case, print x is positive, so it's gonna run x is positive. Okay, no surprise, okay? Sometimes as you are writing code in Python, you can write in the statement pass, okay? Pass does nothing, all right? It's kind of like, you know, just imagine going around in a circle and they say, all right, everybody, why don't we share a memory of what happened this past week, right? And it's your turn and you say pass and you do nothing and then it goes on to the next person, right? So that's what we have. Pass is a keyword and it's not going to do anything. But it's just there so, because remember Python depends on indentation. So you don't have the option of creating curly braces and putting nothing inside. And so sometimes you need to put code in a spot to kind of indicate that, yes, there is code associated with this kind of if statement. I just haven't figured out what code to put there. And so you can put in pass. And that will prevent Python from getting confused about, because you might want to say, you know, if this is the case, do nothing and then try out another statement or something else. But because of the indentation rules, you have to put something there. So you can put in pass, right? So here I've got x is equal to -3 if x is less than 0. Right now we don't have anything there, so we're just going to say pass. It's not going to do anything, and it does nothing, exactly as we expected. Okay, but pass is a useful statement, and sometimes you'll see that in there. Sometimes you'll want to define a function, just have a function there, but you don't want the function to do anything just yet. You can just type in pass. And it basically does, the function does nothing. Okay, I think you're all familiar with this stuff. So we've got else statements, okay, and this is what an else statement looks like in Python, okay. You know, so one thing about if statements is they don't require parentheses, all right. Now, out of habit, I often throw parentheses around my if statements because I still have a heavy R accent when I write Python, okay. So, so sometimes I forget I don't need to include parentheses. And the general recommendation, at least as style guides, is if you don't need to include parentheses, don't include parentheses, right? You are allowed to put parentheses in Python, and especially if you have kind of a compound if statement, which can also get confusing. But if you have a compound if statement, you might want to put parentheses around things to kind of, as far as the evaluation goes. So here I've got x equal to 5, x mod 2, is that equal to 0? If that's true, it's going to say x is even. Otherwise, x is odd, right? And those are the only two possibilities. If it's not even, it has to be an odd number. well, I guess if they're integers. If x isn't an integer, then I don't know. There's no it's neither even nor odd, but anyway, that's, I think we would get some kind of error anyway. So here we run this, we put in x is 5 and we get odd. If I put in 6, I get even. 7 comes back odd. Okay. The else if is combined together into elif. All right. So elif is the else if. And so here I got x is equal to -2. And it runs if x is greater than 0, print x is positive. If x less than 0, print x is negative. Else, print x is 0. So in this case, it's going to print out x is negative, right? And just like the else statements, else if is only going to be evaluated if the statement, if the expression in the if statement is false, right? So the if statement has to be false, otherwise it'll never get evaluated. So here I've got x equal to 5, and it says if x is greater than 0, print x is positive. And then once it does this, it's going to skip everything that has an else. It's going to skip all the elifs and all the elses. So this will never get evaluated. Here it says else if x greater than 3, print x is greater than 3. Else if x less than 0, print x is negative. Else, print x is 0, right? So if I run this, I get x is positive, okay? On the other hand, if I, if instead of elif, if I run this, okay, then it will evaluate this and then be done. Then it will come over here and it will evaluate this, and this will be evaluated, okay? So it's going to print out two things. It's going to print out x is positive and x is greater than 3. And then what happened down here, okay? It got confused because here it says if x is less than 0, print this, else print x is 0. So when we did x equals 5, this came out to be false, so it evaluated the else and it printed x is 0. So that's obviously not what we want. So in this case, you would have to do something, and this would be entirely stupid, but you can do x equal to 0 and evaluate that, and that would work, okay? But this is probably, you know, just be mindful of whether it is that you actually want else if statements or if you just want if statements, okay? There's, in this case, because this one's true, all of these are just skipped. None of these are evaluated, okay? And in this case, every single if statement is being evaluated. So a little bit more work as far as the computer has to compute, but it's not too bad. Okay. Okay. We're all good, right? I don't know. Give me a thumbs up if all of this is easy peasy for you. And then let me give you the first quiz answer for today. All right, I'll look at all those thumbs ups or those yeses or whatever. Okay. First quiz answer for today is B. B as in boy. So it's third week Wednesday, question 1. B as in boy for our first quiz answer. Okay, let's, we can keep going on. Nested conditionals. This is fine. This is sometimes something you have to do. Sometimes it can be simplified, right? So here I've got x is equal to 5. We're going to say if x is greater than 0, or basically if 0 is less than x, then test out if x is less than 10, okay? And if that's the case, then you can print out x is a positive single-digit number. Great, okay? You can combine these with an and statement, so you don't, okay? So this is fine. This is fine. You can do if, and then if that's true, then this, and then evaluate this, okay? probably better if you just combine them together. If 0 is less than x and x is less than 10, then go ahead and do that, okay? And if it's something as simple as that in Python, you can just do 0 less than x less than 10, okay? You can do kind of a compound, see if x is between two values. So these are all allowed. But, you know, depending on the program that you're writing, the script that you're writing, you might need to have nested conditionals, and it's fine, you can do it. Everything again depends on the indentation. So the first level is indented one level, and then the second is indented 2 levels, okay? And by default, anytime you type in a colon in your Jupyter notebook, as soon as you hit enter, it should automatically indent for you, okay? And then you can hit backspace or delete to exit out of the indentation. And I think by default, it puts in spaces, okay? When you type tab on your computer, it's gonna, by default, insert 4 spaces for you. So you can tab, but it's gonna put in basically several spaces. Okay, just a question about syntax. We've got a question. It says, you said Python doesn't use and or, but it works in Jupyter. Why is that? It does work, yes. The and the or, those are what we call bitwise operators, and so they do work. The preference is the and the or. Here, let me look. Let's look up Python and versus ampersand. Okay, all right. So yeah, the ampersands are what we consider bitwise. Okay, and basically it allows us to do kind of vectorized it's a and tests whether both expressions are logically true, while and, when used with true false values, tests if both are true, okay? Empty built-in objects are treatedly typical as false, and built-ins are logically true. If yeah, okay. So in general, okay, because we definitely do use the ampersand, okay, this and symbol. That generally comes later when we are using arrays, okay? So when you have like a vector of true false values, you've got 2 vectors of true false values, and you kind of want to create another vector of kind of the combinations of those things, we'll use the ampersand and the or, and it's going to produce another vector of true false. Whereas the ands are generally going to be reserved, I don't want to say reserved, but for these kind of logical expressions, okay? So yes, you can use this and this, the ampersand and the or, the vertical bar symbols, but those will come later when we are dealing with vectors in NumPy. Okay, so let's get into this programming concept called recursion, okay? And all right, so this is, so recursion, you know, we haven't even gone over like iteration and stuff, but we're gonna introduce this concept of recursion early. And recursion, as far as writing a function goes, means that from within the function, we call the function itself, okay? So on Monday, we talked about, you know, drawing the turtles, and we said, you know what, we can draw a polygon. We created a function for drawing a polygon. And then we created another function called circle, which basically called polygon and said, draw like a 50-sided polygon or an n-sided polygon, okay? So you can call other functions from other functions, and you can even call the function itself from the function, okay? And when you do this, basically, you're going to be kind of running into this almost this infinite loop thing. So every time you use recursion with a function, you need to create what's known as a base case, okay? And a base case is going to basically end the the function. And so the idea is you start off a function, and every time you run the function, it reduces the operation to a smaller version until the operation gets reduced to the base case, and then after the base case is complete, then the rest of the function runs. So here's just a very silly recursion function, okay? And in this recursion function, it's called countdown, and you put in some number n, and what it's going to do is it's going to check to see if n is 0. If n is 0, it's going to print blast off. This is the base case, okay? If n is less than or equal to 0, print blast off, and then that will be done, okay? Otherwise, okay, if n is not 0, okay, which is pretty much going to be every other case, just print the number n, okay? Print the number n, and then call countdown. Call the same function on a smaller version. So it's going to call countdown on n minus 1. Can you guys see what's going to happen here? So we're going to run this, and we're going to call countdown, and we're going to run it with the number 3. So when I run it with the number 3, it's going to come in and it's going to say 3 is 3 less than 0? Nope. Okay, let's do the else. So then it's going to print 3, and then it's going to call countdown on 2. Okay, and then when it calls, and so I've listed out exactly what it's going to happen, right? It outputs the value 3. I should say it prints the value 3. Okay, and then calls itself with n equal to 2. With n equal to 2, n is greater than 0, so it prints the value 2. Calls itself with n equal to 1. And then it executes countdown with n equal to 1. N is greater than 0, so it prints the value 1 and calls itself with n equal to 0. All right, and then it runs countdown with n equal to 0. 0 is not greater than 0, so it prints out the word blast off, okay? And then it returns. So it's a little bit different from a while loop, okay? It's a recursion, okay? Which means it calls itself until it reaches the base case, okay? It's different from while because while will just keep running the same command over and over and over until the statement is false, okay? With recursion, every time you call it, it should be running a smaller version of itself, okay? So you start off with a big problem, and then it reduces the problem into a smaller version, and then it reduces the problem into a smaller version, into a smaller version until it reaches a base case. So I guess in that regard, it's a little bit similar to a while loop in that it keeps going until it reaches some kind of base case, but the difference is that a while loop, you're running the same instructions over and over until the statement is no longer true. With recursion, you're generally running reduced versions of itself until it reaches a base case, which is generally like n is 1 or n is 0 or some kind of thing here, okay? So when I run this on countdown 3, it runs 3, 2, 1 blast off, and I can put in other numbers, and it works as well, okay? So in here, it's gonna reduce itself to a smaller version. Okay, so let's think. Okay, so here's another just a silly and simple example here. We can say print n, okay, which is gonna just print the statement, and it's gonna print it n times, okay? And so basically, we're going to start off with a print give it a string, and we give it an integer n. And if the n is less than or equal to 0, we're going to just quit the function. We're going to quit the function. Okay, this is our base case. Okay. All right. There's no else. We don't have to even bother checking an else. Okay. If this is not true, then we're going to just print s. I mean, we could throw in an else. It doesn't matter. Okay. But we're going to just print the string that is provided here. And then we call print n, and we call basically the same function on a smaller version of itself. So we're going to call print n, the same name of the function with s, but this time a reduced version, and it's going to be n minus 1. Okay, so that's the function. We say print n, we say hello, comma 3, and it's going to print hello 3 times, okay? Because it prints it hello, then it calls n minus 2, n minus 1, so it calls it with print 2, and then after that runs, it's going to call it with print 1, and after print 1 runs, it calls print s with 0, and when with print s0 runs, then it just stops. The function ends. Okay, so a mathematical function that is pretty much the perfect candidate for recursion is the factorial function, right? So if you think of what is 4 factorial is 4 times a reduced version of itself. And it's going to be 4 times 3 factorial. And then what's 3 factorial? 3 is 3 times 2 factorial. 2 factorial is 2 times 1 factorial. 1 is 1 times 0 factorial, and 0 factorial is our base case. 0 factorial is 1. Okay, so we're going to we can run this recursively, okay, using the factorial function, and this is how it runs. Okay, we're going to define factorial. If n is less than or equal to 0, if it's 0, return 1. This is our base case. Okay, and then for everything else, return, basically it's n, whatever the number it is, times 3 factorial. Okay, does that kind of make sense what's happening here? As far as we have designed this recursively. Okay. All right, so I'm going to run that, and then I can do 4 factorial, and 4 times 3 times 2 times 1 is 24. We can call it on 5. 5 factorial is 120, and indeed this is what we expect from the factorial function. Okay, recursion it's like a little brain teaser and little puzzles that you've got to figure out, right? So someone might say, hey, I want you to write this function recursively, okay? And there's some really good examples in the textbook, and I'll probably put these in your homework here, okay? Or you know what? I don't even have to show you I'll pull up the actual PDF here. So I don't know. Are you guys familiar with like fractals and stuff? So fractals are basically like recursions, okay, on smaller versions of itself. The only unfortunate thing, I want to put these in your homework. The only unfortunate thing is that I don't know how to get turtle graphics to show up in your homework. So I might have to have you like take screenshots of your turtle graphics work here, okay? But here is the Koch curve, and this is a fractal, okay? And basically the base case is okay. Okay. So this is your base case, okay? You have a segment, okay, and you divide it into 3 segments. In the center segment, you put a little, I don't know, whatever you call this, a little triangle, okay? And then you can call it recursively, all right? And then so on this piece, okay, you're gonna basically take this same pattern of taking the segment. This segment gets a little triangle put into it, okay? This segment, okay, gets a little triangle put into it. This segment gets a little triangle put into it. And the last segment, so we went from 1 into now 4 segments. Each of those 4 segments gets a little triangle put into it, okay? And now I've got, what is this, 16 segments. Each of those 16 segments gets, like this piece down here gets a little triangle put into it. This gets a little triangle. So all these little triangles get put in, and then you keep doing this, okay? And so the length of the curve gets longer and longer and longer, and whatever. And this is like, I guess, you know, now you can get into like fractals and Cantor sets and stuff like that. That's not the point, but it's basically you're going to just keep running some version of this thing recursively here, okay? And so you're gonna I think I'm gonna assign this as part of your homework, although I'm not sure how to get proof that you did it, because unfortunately with these Jupyter notebooks you can't include the printout of the turtle graphic. So I might just have you like screenshot it and put it in a separate document. Okay. But anyway, it's kind of fun. It can be frustrating at first. All right, I'll just tell you right now. It can be a little frustrating at first trying to figure out recursion things, okay? But then when you do it, you're gonna feel like a genius. You're gonna be like, yes, I figured this out. So it's just like it's like solving brain teasers and brain puzzles, right? Do you guys like that? I enjoy solving puzzles. But you know, maybe you don't like it. Okay. I want to, so now a totally detour. I'm going to deviate from the book. The book covers lists. It starts covering lists not until in a few chapters, chapter 10 here. But I'm going to go ahead and I'm going to just start covering list methods and certain things that we can do. And then eventually we'll catch up, okay? The book will catch up and you know, we'll cover things you know, appropriately as well. So let me just talk about lists. List is a basic data structure in Python, okay? And the base types, base data structures in Python are quite different from R than you know, if you're coming from R, everybody took stats 20, and so you have some experience with R. Some of these things are quite different, right? So the list is kind of like the list in R in that it can take mixed data types, okay? Python actually, in base Python, there's no vector equivalent, okay? You have to import a package called NumPy to have the vector equivalent, where everything has to be of the same data type. So we'll talk about NumPy later, and you know, NumPy I think was covered in one of your early data camp or data camp courses. So you're at least familiar with this NumPy thing exists. But let me just talk a little bit about lists, okay? You create a list using a single square bracket, right? So single square bracket, you put commas in there, separate out the elements. So here I've created a list called fam, and it's got a mix of names. So we've got Liz, Emma, mom, and dad, and then we have numbers here, and these are kind of like their heights in meters, I guess. Okay, so Liz would be 1.73 meters, Emma is 1.68 meters, dad is 1.89 meters, and we're going to call this our family, okay? Lists can also be lists of lists. So here I have fam2, this is a list, okay? And within the list, I have lists, okay? So fam2 is a list of lists. Each list, there's 4 lists inside fam2. Each list has 2 values, a name and a number, okay? And I got 4 of those, and that creates fam2. So this is a list of lists. And when you just type in the name, it prints it out. and you type it in, and this is what it looks like. So this is how lists get printed out. And when they get printed out, you can tell it's a list because there's square brackets and there's commas. Those are the key pieces. If you see square brackets and commas, that's going to be a list, okay? So Python has these nice features in that when it prints it out, you can generally tell exactly what it is, right? If you see a number and there's no decimal, you're going to know it's an integer. If you see a number and there's a decimal, it's a float. If you see square brackets and commas, it's a list, okay? So you can subset lists using single square brackets, almost exactly the same way you subset vectors and lists in R, except we're zero indexed, okay? So here, fam, the first element is Liz, so I would do fam single square bracket 0 is Liz. Okay, what is fam2 single square bracket 0? What's the first element in fam2? All right, well, I'll pretend like you answered my question. And the first answer is the first element is a list of 2 elements. It's Liz. Oh, thank you, Emil. Thank you for answering my question. I appreciate it. Okay. All right, so yes, the first element here is a list with two values in it. Okay, and then so you can then say, all right, I want the first element and the first element here. So you can do square bracket 0, and that's going to pull out Liz, exactly as you expect, right? You can also have negative, okay? Negative values here, different from R, it's going to give us the last element, okay? It's going to give us the last element. So counting backwards, fam -1 will give me 1.89, okay? In R, this would mean something like give me everything but the first element. In Python, negative numbers means give me one element, but start at the end, okay? So here, we're looking at this list, and we go backwards. So this is -1, -2, -3, -4, -5, 6, 7, and 8, -8, okay? And again, you can do the same thing with nested lists. So -1 would be this list, and then if I do -1 there, then the first element, the last element in that thing would be 1.89. So here's that, and then -1 gives me that 1.89. All right. You can do what's called a list slice, okay? And this allows you to pick multiple elements inside a list, okay? And you can think of a slice happening as far as how these things work. You can think of slices happening at the commas, okay? So here I've got the list fam, and I'm going to say I want to slice from 1 to 3, okay? So we're going to slice it from the first comma to the third comma. You have to also imagine there's a 0 comma and a 9 comma. There's no actual commas there, but you could pretend that there are, right? So I'm going to slice from 1 to 3, and I'm going to get back 1.73 in Emma. Okay. So if I do 1:2, if I slice that, then it's just going to be this number, 1.73, okay? And that's equivalent to having no slice, okay, right? If I don't use the colon, and if I just say, give me the second element index 1, second element is index 1, that gives me 1.73, okay? There's a difference though. There's a difference between this and this. This gives you just the integer, 1.73, okay? This gives you the list that has been sliced. So when you slice a list, the result back is a slice, is a list itself. So this is a list with the element 1.73, okay? So again, Python keeps it all clear, right? If I ask what's the type of this, it's going to tell me it's a list. And what's this? This is just a floating number, right? If you do, if you try to slice 1:1, what do you think this is going to return? Okay, the fact that you're slicing means it's going to return a list. The fact that you're starting at the first comma and ending at the first comma means there's nothing in between there. So it's going to give you back an empty list. It's going to give you back this. You get back square bracket, nothing inside square bracket. Okay. 0:2 will give you basically the first 2 elements, a list with the first 2 elements. 6:8, okay. So if you count 1, 2, 3, 4, 5, 6, 7, okay? So the 6th is right here, and then I guess, I'm sorry, you have to imagine an 8th comma that doesn't, invisible right there. So it's gonna give us dad through 1.89, okay? If you're gonna go to the end, you can just leave off the last, or if you're gonna start at 0, you can also leave off the first. So this is gonna give you everything from the 2nd comma forward, and this is gonna give you everything up to the 4th comma, okay? Which is exactly what we have. Well, everything up to the 4th comma. Okay, and then if you put in nothing colon nothing, this will just give you a copy of the list. All right? This is technically what's called a shallow copy. I don't feel like getting into it right now, but you're gonna get a shallow copy, right? If you try to subset a list and you don't give it any values inside, Python gets mad at you, okay? It says, hey, that's not okay. You can't tell me to slice the index, slice the list, and give me nothing, okay? So it doesn't like that, right? And then, you know, if you want to do like negative numbers, right? So -5 colon -2, you're going to start at the -5th comma. So what is that? 1, 2, 3, 4, 5. And you're going to end up at the -2 comma. So I think that'll go Emma through 1 point. Oh, wait, hang on. This is everything, and then, oh, it goes backwards here. Okay, what happens when slicing a list that has lists inside? Yeah, it works the same way. Here is, where did that other list go? Okay, so let me just look at fam2. Here's that list. Okay, and so I can do fam2, and so you imagine I can go from the 1st to the 4th comma. 1, 2, 3. Oh, or let's just do 1st through the 3rd comma, and it will give me back a list from here to here. Okay, so we can do that. And so it's just kind of on the outer list, right? From the 1st to the 3rd. Thanks. Okay. Ooh, how much time do I have? Okay. Lists are mutable, okay, and we'll talk about this in more depth, I guess, when we get to the lists chapter in the textbook. But lists are mutable, meaning here I'm going to create this list, okay. If you slice twice in a row, will it extract from the specific list inside the? Okay, so I guess it depends, right? So here, if I try to do this, okay, and then and let's say I slice, so here I can really only subset at this point, okay? I can ask for the first element, and then I can ask for, I can do this, okay? If I try to do something like this, this will give me back the first thing. So you can kind of chain the subsetting or the slicing operations here. So here we're going to say from fam2, slice from the 1st to the 3rd comma, and that gives me this thing. And from here, maybe I just want the 0 index element, which is this, and from there, slice from the 0 to the 1st comma, which will give me this or something. I don't know. I mean, obviously, we could have done this more efficiently, but you are able to kind of chain slicing and subsetting commands. Okay. So lists are mutable. We have reference semantics. Okay. So here is I've got list fam. Okay. I'm going to create. I'm going to assign fam to the name second. Okay. And second references fam. It's not a copy. They both reference the same object. This is the key here. All right. So if I change the 0 element in second, okay, to sister, okay, sister is going to change in second, and fam will also change because they're both referencing the same object. Okay. So we start off with the list where it's Liz, I change the element in second, the first element, to sister, the 0 index element to sister. And it also changes when I say print second and print fam. Fam also reflects the change because they are both referencing the same object. Here, I create a copy, okay? I can do second is equal to fam, and I've done basically an empty slice, or not empty slice, a full slice, so that it creates a copy of this, okay? And so, so the difference here is basically for fam, I put in square bracket, colon square bracket, and so that's gonna create a copy, and therefore when I change the 0 index element in second to sister and I print that out, Liz will change to sister, but then the original list fam remains unchanged because they are referencing their different objects now, okay? So here, this creates a copy, okay? You can also, so this is a quick way to make a copy. You can also, there's a copy method. You can just do fam.copy and it's gonna create a copy of it, and that's equivalent, okay? And so you can do that. All right. Here I make another copy of fam, okay? And we're gonna call that third. We're gonna change the element, the third element in, or I'm sorry, the second element, the index 1 element to 1.65. And again, fam remains unchanged when I do this, okay? So here's the, here's third when I first copy it. Here's the list third after I modify it. And here is the original list fam, which is unchanged, right? So these are, this is what happens when you make copies. Okay, oh, I'm gonna run out of time. All right, and then you can also use slicing operations in conjunction with assignment to change values. So here you can say like the elements from, if I wanna slice from first to 3, I got 1.73 in Emma. I can change that to 1.8 in Jenny, okay? And so this is what it was originally, and then I can replace these, those values there, okay? I guess I'll have to talk about these list methods at another time, okay? So we'll keep moving forward in our textbook, and then, and I guess I'll also be talking about some of these other topics as well. Okay. Does list fam also work for copying? I'm not sure. I'm trying to think off the top of my head. It's not, probably it would be my guess. Okay, so here's fam. Let's do list fam, and we're gonna call this, is it copy? Copy maybe? We'll call this list 2. Okay, that's a terrible name for a list, by the way. But I can't, it's hard to think of new names here. All right, so here's list 2. Let's see, this is what we have. All right, let's change list 2, the first element to 1.9, okay? And okay, so let's look at list 2. List 2 looks like that. And then let's see what fam looks like. Okay, yeah, so fam is unaffected. So when you do this, it creates a copy. Oh, next quiz answer. Thank you for the reminder. Next quiz answer is A as in apple. A as in apple. All right, we'll end here for today. I'll post up the edited notes, and we'll see you guys on Friday. When's the midterm? I don't know yet, okay? I'm sorry. I'll make sure you get at least a week's notice before I thrust a midterm upon you, okay? So I have to figure out exactly how to go about running a midterm remotely, and I'm checking out a couple options. And once I feel good about that, I will let you know, and then I'll let you know how to prepare for it. How many midterms do we have? Did I put that in the syllabus? I was just planning on 1. planning on having one midterm and one final, but if you guys want more, I guess we can do more. I don't think we want to do more, right? Finalized grade breakdown. Did I not? Okay. Have I not created one yet? I am so sorry. I'm just like trying to juggle everything right now. Okay. That is good. Okay. I'll let me review what I have written in the syllabus, and I'll try to get everything finalized for you guys. Okay. Or none, that's fine too. Okay. I'll try to get everything finalized, and I'll let you know. Okay. I will my goal is to be fair. Okay. So I won't try to do anything mean, but I also want to make sure I can at least test you guys to make sure you're practicing and learning some stuff. So probably not 0, but we'll but we can make them lower stakes as well. So okay, I'm sorry for not having a finalized syllabus. I'll get on that. Okay, we'll see you guys on Friday, and have a good day.